building software, especially in healthcare, is pretty hard. And the traditional way of building these applications usually suffer from some of the following that I'm going to describe. Now, let's just take a look at how we usually go about building software and why in healthcare specifically, this doesn't usually apply very well. So let's take a simple hospital, and let's say you are the developer for this hospital, and they're asking you to build a particular system, right? So usually this is the invoicing slash patient registration system to begin with, but then it usually evolves to, let's say, their OPD management, their outpatient clinic. Now, I've seen this in a lot of places where the accounting part of the software is done relatively well, but when it comes to the clinical side of things, it usually starts breaking down really quickly. And there are a few reasons for this. The main ones being you can either build healthcare software as custom software. You build it all by yourself. You use a database of your choice. You write the schemas and the data structure yourself. Or you could procure, or you could buy a proprietary software that does something well. So this might, for example, be let's say an ophthalmology suite that does ophthalmology very well, right? Or it could be an ERP suite, like enterprise resource management suite, that does billing, invoicing, inventory management well. So the other option is that you have these mega suites that are coming up, and they do everything, right? So they do everything from patient registration to invoicing and billing to actual clinical data capture. So there are problems with all of these approaches, and I just want to break it down one by one, what the problems with each of these approaches are. So let's take custom software to begin with. So what you end up doing is that you start modeling the domain yourself, right? Like, so you need to understand how a clinician thinks and how the workflow of a hospital is modeled. And if you follow this book, Domain Driven Design, it essentially asks you to go talk to the people who are actually doing this. So the doctors and the practitioners understand what the workflow is, and then come back and model your software accordingly. Now, this has a few issues. Like, the one of the issues is obviously the software developer sitting and talking to doctors just to understand the workflow is not the most efficient use of their time. And secondly, most doctors don't really know what the correct standard workflows are, because there is no standard in most of these situations. So what might be ideal for one particular practitioner may not make sense for another. And that is why we see most healthcare software cannot survive without customization. And I'm not talking about mild customization like theming or something. It's heavy customization to just change the nature of the software itself. So when you have such complex workflows that are non-standard throughout different entities, it's really hard for a single team or a single developer to go and sit down with a healthcare professional and understand the domain, right? So an example of this would be, I've seen a lot of people represent blood pressure as they'll want to capture blood pressure. So usually the doctors think of this as, it's a 120/80 would probably be 120 is systolic and 80 is diastolic. And they write it down as 120/80, right? So the natural tendency of the doctor is to tell the software developer that, hey, I want to capture blood pressure. I want it to be 120/80. And the developer just goes, okay, so this is going to be a string field, right? Because it has a slash in it. They don't really understand that these are two separate values. So there is 120, that's the systolic blood pressure, and 80, that's the diastolic blood pressure. They model it together as 120/80 being blood pressure, which is in a text string field, right? So now you can obviously understand what the problem with this modeling approach is. You want to analyze how many people have blood pressure elevated above a certain value, you need to go look at the string that's stored in the database, split it by the slash, and then take the first value. And we've seen it, like if things can go wrong, things will go wrong. So if you allow a string field, people are going to type like just systolic 120. They're actually going to put SYSTOLIC in the field, and there are going to be some random characters. So you lose out a lot of data when you're trying to do analytics if you, for example, capture this as a string instead of two numbers, which they actually are. So that's just a simple example. But the more insidious sort of manifestation of developing software, custom software yourself, and doing it one by one is that you usually tend to focus on a particular use case for a particular software. So for example, let's say you want to do COVID monitoring, or you want to do remote patient monitoring, or you just want to do simple patient registration. So each of these applications usually has one set of workflows that it needs to go through. And when a developer thinks about the data model, they design it in such a way that it just fits that particular use case. All right. So let's go back to the same blood pressure example. So you may want to record the blood pressure of a patient while you're registering them. So that developer might record it as a string field, say 120/80. And let's say that you also have another application that you want to develop as part of the outpatient clinic, and there you have this field as well. Now it may not be the same developer, it may be another one, or it may even be the same developer. For some reason, they will not use the same table to represent the blood pressure value, but they will instead put that in another table that's dependent on this workflow. So they'll instead model it as OPD consultation, right? And the same blood pressure value is again present in the OPD consultation. So now you want to ask a question like, okay, I want to understand all the blood pressure readings of my patient. You don't know where all of this data is. And this problem is actually made even worse by microservices, which all use different database technologies even. So it's hard to use, it's hard to make sense of the data when you're building custom software, especially if there are multiple teams working on it and you are modeling the same data in multiple places in different databases, right? So it just becomes an integration nightmare when you want to make sense of this data and actually derive value out of all this data that you're capturing. So let's take a look at the next approach, which is buying standalone software. And many people do this. It's a very common tactic. So the approach here is that you take software that does one thing really well, and then you just try to take best of breeds of all of these different software and put it together. So an example would be you procure software that does patient registration, inventory management, and billing very well. So this is usually called ERP, or Enterprise Resource Management. And there are hundreds of very cheap software that already does this very well. Like, for example, Zoho, Salesforce is another one. SAP is another not so cheap one, but it's very expensive. But people do use it for all of these financial modules. And then you have software specific to a specialty, let's say ophthalmology or cardiology. And they do this one single thing really well. And the hospital or the institution takes this and starts using this particular software. Now, it seems like a good approach, but what ends up happening is that you need to do deep integration between all of these different software to make it viable. So it's almost like putting together a Frankenstein monster where you have all of these different solutions built by different companies and vendors, and putting them together takes all of the effort, right? And sometimes you can even host all of this software yourself on your prem, and you're able to write some glue integration code that makes sure that, when a patient registers in the registration system, it also shows up in the ophthalmology application. But it takes a significant amount of effort, and it's not easy. And especially if all of these, if the vendor or the software developer is not offering this knowledge of how to integrate it with somebody else, it becomes really hard, right? And usually the integration is through some older standards, like some people use HL7 Fire. I mean, HL7 Fire is pretty rare. Some people use V2 mostly, HL7 V2, to notify what's going on in this particular application. And they try to integrate with all of these other applications through messaging one another, right? And CCDA is another common approach that's taken for, just sending out data once it's captured. Now, usually, most of the time, this data is lossy. Like, they don't output all of the data. And even if they do integrating between different software vendors who have, again, like, developed their own schemas and their own databases, and they have their own data structure, it's hard because they did not think about integrating with all of these other pieces, right? So you have this Frankenstein kind of an approach where everything comes together, but it doesn't really like glue or gel well with one another, right? And sometimes you even have these places where they don't do integration. You just, the doctors and the nurses have to re-enter the data from one system into another. So they look at this one system that does something, and they copy over the data to another system by manually sitting down and typing. Obviously, I can go on about the disadvantages of doing that, like just like the medical errors alone that end up happening if you have to copy something manually is like insane. But people do that, and that's a very common practice when using multiple softwares from multiple vendors, because the cost of integration is sometimes even higher than the cost of purchasing this software. Right? So now that actually brings us to a nice segue into these mega suites, right? So mega suites are, like, since integrating multiple software is hard, why don't you try and build all of the software yourself? So this is big companies like Epic, Cerner, they all are technically mega suites. And what they do is they offer everything from patient registration to the clinical workflows. They do everything, and they do it relatively well. Now, you may see like, okay, that's the solution, right? Like, so we just go with mega suites, and what is the issue? So the problem with mega suites is that once you're into them, so firstly, they're like ridiculously expensive in most places. So they're extremely expensive because they have to do everything and they have to like manage everything. And there are only a few players who can do all of this relatively well, right? So they're expensive because they have that monopoly over doing all of these workflows. So they basically catch you by the neck, right? And once you're into the ecosystem, right? Like I'm trying to think of this as in the way how Apple kind of traps you in the ecosystem once you're in. So you can use software that the same software developer or the vendor provides you, but as soon as you want to do something else with it, so the thing is, healthcare evolves pretty fast, and there are these new use cases that come up, and a practitioner might want to optimize their workflows. And whenever this problem hits, right, you are either in a deadlock with the software vendor because you're asking them for these updates and they're just, they have to focus on 100 other things, so you never get these updates, or it becomes like really challenging to actually integrate something with them because their whole business model, the mega suites business model, is based around the fact that they provide everything, and usually they make it by design to make it hard to integrate, right? So if you're building an app on top of the mega suite, it is usually very hard to integrate. And we've seen this firsthand with a lot of these vendors. So it's not something new. And if you're building like a Smart on Fire on top of Epic, you know exactly what you have to go through. So it's not, it's by design because their business model benefits from external software vendors finding it challenging to do things that they themselves do internally, right? So if you ask me, can somebody do the OPD module better than Epic? Yes, obviously. There are hundreds of vendors who can do the OPD module very specifically, like let's say ambulatory care, much better than what Epic does. But if they cannot integrate deeply into the mega suite, and usually they make it really hard. They just just stick around to the rules and regulations laid by, for example, the US government. So you have the ONC just pleading all of these vendors to, like, please be interoperable, please, like, you need to provide at least these APIs. But then these APIs are not enough to build an app to integrate deeply into your workflow. It's usually, again, like it's sort of a Frankenstein thing, where the external app is not deeply integrated, and you just find that the mega suite offers something that's just a little easier. It may not be as good as the other software, but you end up just using the mega suite's solution, right? So this is by design. And the other problem here is that you are not in control of your data if you go with most of these mega suites. So they take almost all control of this data, and although you put all of your hard work as a healthcare organization, it's your staff and it's the doctors and it's the nurses who are actually entering this data, and the patient, they're coming to your institution. But the mega suite vendors, they usually make it really hard for you to access your own information, right? So even for something like research, they usually charge some money for you to get access to this data. And if you want to, move away from this vendor to somebody else and just getting a data dump, good luck with that. Like, it's usually just easier to forget about it and move from scratch, and like start from scratch and just rebuild all of your database from the beginning. So mega suites do have this issue, and usually they do most things relatively okay, but then they're expensive, and whenever there is innovation that is needed on top of your existing suite, they fall very short. So you cannot integrate that easily, and you cannot take the data out that easily. You cannot move to somebody else that easily. Whereas like standalone software, at least they know that they are not working in isolation. They know that they have to play nice with other people. So they at least offer some sort of integrations like HL7v2 and CCDA. And some people even offer pretty good APIs. They are their own proprietary APIs, but they do offer these APIs. Whereas mega suites sometimes even charge you per API call for calling their APIs, and they charge this to the developer because they know that they have the data, they know that they have a monopoly on this data, and it's up to the external developer to come and pay them, and it's a huge market, it's a huge racket, to be honest. So these are the options that we have today, right? Like you either build custom software which doesn't really scale as the complexity increases. You start modeling things differently, and it's a nightmare most of the time. And then you have the standalone pieces that work well for one particular workflow, but then integrating this with other standalone software becomes really hard. And sometimes people just don't integrate at all. And then you have these mega suites, which are, I would say, the most malignant of these three options. Although they seem to do everything okay and it seems to fit your use cases, once your data is in, most of the times you can forget about using it for other use cases and actually having ownership of this data. And integrating some other piece of code, some external component, also becomes really hard. Now let's look at the fourth approach, which I think is a lot more modern than the previous three traditional approaches. And this is that of the healthcare data platform, or some people call it health data platform, clinical data platform. So the idea here is that you have a component which stores all of your health data. So this is like a longitudinal history of the patient. And you have applications that come and go that use the health data platform. They commit data to the health data platform. But these applications are separate from the data. The applications themselves do not store the data inside their own proprietary schemas and their own database technologies, but instead use the health data platform. And these applications can be built. They can be built by your organization. That could be custom solutions, or it could be bought. It could be standalone solutions, or it could be a suite of multiple solutions provided by someone. But the important factor here is that the data platform is completely separate from the applications that are on top of it. And the data platform also needs to be vendor neutral. So it's a very important part of this. So if one specific company is offering you a data platform with their own proprietary APIs, don't fall for it. That's not really a healthcare data platform. What you need is a vendor agnostic platform that has all of your data. You have standard APIs to communicate with this healthcare data platform. So you, as an organization, you have full control over your data. And the application developers that are building these apps on top, or you can even buy these apps, they also have full control and full access to this clinical data platform. Okay, and the vendor who's selling you the clinical data platform need not be the same software vendor who is providing you with all of these applications. And in fact, it's best if they are separate, because that ensures that you can always switch between vendors, and you have this contract between the apps and the clinical data platform on what they can send and what they can retrieve, and you don't tie yourself down to one specific vendor, right? Now, this approach is a little more expensive to begin with, right? You need to understand the complexity involved in separating the platform from the applications. Initially, there aren't that many software vendors who are already providing software on top of a clinical or a health data platform. But in the long term, this is the only option that actually makes sense. If you think about it, you cannot have each application come and go and just take the data along with it, right? You, as an organization, you want to have a longitudinal history of the patient, and this patient lives for, let's say, 100 years, or even like say 80 years. The average lifespan of a traditional software application today is 10 years. So you change software every 10 years. And if you're going to lose this data, or if this data transformation is going to be lossy every 10 years, you're going to basically end up with no data about this patient by the end of the patient's lifespan, right? So what you want is, you want a standard-based clinical healthcare or a health data platform. Some people also call it a CDR, a clinical data repository. And then you want to have applications built on top of this that is completely independent of the data platform, but they use the APIs. They use the contract with the health data platform to communicate and get the data and push the data back. So an example of how this would look like is that you buy your health data platform, or you can even use an open source version of this data platform, and you set it up in your clinic. And let's say for registration, or for a very specific use case, you call software vendor A, and you take their software and then you use it. But all of this data is naturally committed into the health data repository. So all of this data is already present in this clinical repository. Now, let's say you take another ophthalmology application, and they are, let's say, using the same exact contract and the same exact health data platform APIs. The data is already there. You don't need to do any integration and monkey work in order to patch these things up. So this application vendor who developed the ophthalmology application can independently develop all of their features, just keeping the healthcare data platform APIs in mind. They don't need to think about this registration application. They commit data directly to the health data platform. The registration application also commits data directly to the platform, and they reuse the data across both of these applications. So the only way this is possible is if you use standards, and if you have something that's that everybody agrees for the health data platform. And this is actually already happening for some parts of healthcare. So if you take DICOM, for example, DICOM is a very good example of how they democratized the protocols for the protocols from the modalities, right? So you have a CT machine, or you have an X-ray machine, or you have an MRI machine. All of these machines are like multi-million-dollar equipments that you have to buy and you have to maintain, right? So it doesn't make sense if each of these machines come with their own software, and you need to use, let's say, you need to use GE software in order to operate a GE machine, and you need Philips software in order to operate a Philips machine. Doesn't make sense. So all of these vendors came together and they're like, okay, we need a standard. We need to be able to operate with each other's software. So now you have DICOM. So one modality is able to just communicate with a DICOM server, a DICOM node, and a PAC system also communicates with the same DICOM node. And you're able to, retrieve images. You're able to list all of the images that are, all of the studies. And all of this is done through standard protocols. So you can have an imaging PACS solution that is not built by Philips or GE and still interoperate with their modalities and their machines. So it's just taking that to all of structured data for a clinic. So instead of coming up and building all of these things yourself and putting it in, either mega suites or custom software, put it inside a standard clinical data repository, put it inside the digital health platform, and you have freedom from all of these software vendors just taking the data along with them when they leave. All of the data stays. You throw away these software as and when you choose. You bring in new players who are doing this much better. So it just overall encourages competition between these vendors, and you have a few standard clinical data platform vendors who offer these APIs. And that is the main approach of the digital health platform. And it's drastically different from the traditional approach where you just build software for building software and just, you focus on the use case. For you to even work with a digital healthcare platform, you need to think about the data models, and you need to, think about how you are going to operate with these APIs. Same with DICOM, right? So if somebody is building a software module on top of DICOM, they need to understand the DICOM protocol and how the images are stored and how the slices are actually stored. They cannot just go with whatever they choose, and they cannot just start modeling the software in any way they want. They need to adopt the DICOM protocol, and they need to work with the DICOM protocol. And that's the same contract for the machines as well. So similarly, if you have all applications thinking about the data structures, so before they commit something like blood pressure, they need to understand how this should be modeled and how this should be stored in the clinical data repository, even before the application gets built. Then you actually have true interoperability. An application can be bought from somebody else, and you can build your own custom apps. And as long as they use the same protocols and the same APIs, they just work seamlessly with one another. So you can think of, there are multiple use cases to this. Like you can have a government which has one single clinical data repository. I think that's what's happening right now in Barcelona and the Catalan region. So you have one single clinical data repository, and each of the hospitals can build or procure their own software that operates with the clinical data repository. So this can be a national clinical data repository, or it can be at the level of an organization. So for example, you could be a chain of hospitals around a particular region, and you may want to have one clinical data repository or a digital health platform that serves all of your different branches. So all of your data is uniform and it's present, but each of these centers that you have may have their own workflows and their own requirements. So you can either build or you can buy applications that work with the clinical data repository to meet these requirements. And again, it can also be at the level of a single clinic, but then the benefit that you get here is that you are able to buy and procure multiple apps that you want. So even if you take a single clinic, one department may want different requirements from another. So cardiology and an ophthalmology app can work side by side on the same clinical data repository, and they just commit the same information about the patient, and you still maintain this longitudinal data about this patient. So again, most of this is to derive value out of this information. And even if you think about a data platform, it's the starting point, right? Like you have all of this data now. Then you can think about what you want to do with this data. So whether it be it for optimizing your insurance claims or optimizing how your patients end up and getting better outcomes out of your data, then your true journey starts. I think most of us are stuck in the phase where We have tons of data, but then most of this data does not make sense. And it's just a mess. To the cost of just extracting all of this nonsense data and making it structured is costing us so much that we don't even feel like doing anything with this data. Right. So once we have a data platform which can solve this immediately for us, then I think it just opens up a whole new level of interaction. And again, like with AI coming up, I think it just will get more and more pronounced, because you, even with these large language models able to understand unstructured data, you still need to store it in a proper structured way before you can run reliable queries on it. Right. So I think the future looks good, but people need to understand that the healthcare data platform approach is significantly different from the traditional approach of building software. So again, we'll go more into details about what we can actually consider as a healthcare data platform and some options out there. But I just want to make you understand how this approach itself is different. We are separating the apps from the data, and that itself is a significant step in moving to a more value-based, healthcare outcome-based process, rather than just taking software that you need for that particular use case and just going along with. It's almost like living every day as you get up just to survive, as opposed to having a routine and thriving and having your own set of principles, right? So that's the difference between like use case based software and healthcare data platforms, where you have the standard, you have applications that come and go, you're able to procure and build these things that you want. And I think it's a significantly better approach than all the three that I previously mentioned.